This session is on climate change readiness of Discoms, a term which is very in nowadays. The topics that we are going to cover is the guidelines or standards for power equipment, generation, transmission and distribution, derating owing to higher ambient temperature in India, flood and hurricane planning, designs, operational limits and public safety. High cost of urban underground cable replacement and Discom practices in cable asset utilization for load growth and upcoming EV charging scenarios. Fire safety policies for megawatt scale batteries in high ambient temperatures. New technologies for managing real-time temperature in NMS, ADMS and digital twin. Management of natural earthquakes and tsunamis. Management of cyber attacks and resiliency. So for this, may I invite the chair and moderator, Mr. Ravi Sitapati, advisor ISGF and chairman Bhubaneswar INC Canada. Ladies and gentlemen, please give him a round of applause and welcome Mr. Ravi Sitapati. So please. The other speakers for this session are Mr. Aman Prijono Vasitowadi, Executive Vice President, Development, Sulawesi, Maluku, Papua and Nusa Tenggara Region, Indonesia. I invite you to join on the dais, please. Yeah, welcome. We have Mr. R.R. Mehta, Advisor, Reliance Infrastructure. I invite you to join on the dais, sir. Let's welcome him. We have another speaker of the session, Mr. Shenbagam Mantiram, CEO, TP Central Odisha Distribution Company Limited. Please join me in welcoming him. Request Mr. Shenbagam to join on the stage. Then we have Mr. S. Srinivasan, Executive Vice President and Head of Engineering, L&T Power Transmission and Distribution, is also the member of ISGF Board of Governors. I would request Mr. Srinivasan to please join on the stage, please. Now I hand over the stage to Shri Ravi Sitapati ji to lead us the session forward. Over to you, sir.
Anyway, while we get started, I'll just use the mic. Yeah, I don't know. There's two slides. Yeah, So thank you all. I think this is going to be the beginning of a few conversations at several conferences going forward. And I thank Reji for this. It's going to ask a lot of questions. Some of the answers may be nascent and new. Some of the answers will be no big deal. You know what, we can manage life. And some will be, we have to start making changes. So let me open it up with three broad themes. One is, we are in the long-range planning and asset management business. Everything we touch runs for 50, 60 years. So it's not 4 or 5 years that we run and then we can say, okay, we throw it away and then we start something else. So whatever we have installed in the 1950s and 60s, we are still operating with it. But climate has changed. So all the standards of those days, whatever the standards may be, and I'll just have 2 slides on it, we need to manage that for today's condition, even though it was bought for yesterday's condition. The second issue is, with respect to load growth, and Reji talked about it, with respect to air conditioning load, electric vehicle load, cooking load, the whole world is electrifying because it's a cleaner source. How is that load growth going to basically be managed with a higher ambient? So that's a sort of right now here type problem. And the next is, if we were to buy for tomorrow, what will I specify? And unfortunately, the gentleman from BIS is not here. I was really hoping he was going to be here. I need to know what is going to be the new ambient temperature for the new standards for all of you to purchase. Is it going to be the same? Is it going to be different? And if it's going to be different, why? What will the OEMs react to when they write the new standard? Or is it, they'll say, no problem, just raise the ambient temperature, we'll put a new number on our nameplate, it's good enough. So with that, let me just, I've got 2 slides and it just raises questions, it doesn't sort of answer. So the first is, we all know we got higher ambient temperatures. Even though the world talks of 2.2 degrees, it's all very nice for COP27, COP26, COP21. India has seen 3 times that level of rise. Today, relative to when I was a young man, the temperatures at 48 degrees, 50 degrees are being approached. It is being approached for days on end sometimes, maybe 3 days, 4 days, 7 days. It's still small relative to 365, but it nevertheless is. So the question is, for 10-day LTRs, 3-day LTRs, those of you in asset management, we talked of asset management. I was in asset management for a long time. Your question is very valid, by the way. We will talk about it later. It's an issue to manage. We have all these assets that we have to run, and they have to run no matter what the conditions are. We always have overhead lines. We talk of hurricanes, and maybe Shanbagam will talk about that. He is right in the hot spot here. The question is then, is because it's cheap. So if you have to put it underground, all that is a secondary issue to say, how do we manage hurricanes and floods? Wind is very high these days. In fact, the wind gusts today all around the world have increased by almost 45%. In the United States, it's killing Southeast United States every few months. Look at the disasters, billion-dollar disasters every few months, because the wind speeds are so high. And then we have the whole issue as an operator. We have to look at ROA and ROI, which is what our regulator wants. So now the question is, if you're constantly going to do damage control, what does that mean to regulation? What does that mean to recovery of capex? What does that mean to a whole host of things? In some cases, the state will come and bail you out as act of God. In few jurisdictions, the state may not be willing to come and act as force majeure clause. So then who bears it? Those kind of things. So I had put some thoughts on that, and we will talk about those issues as well. But primarily, I want to talk about temperatures, right? Today we are sitting at 48 to 50 degrees, as I told you. You know what the BIS said yesterday? I had a chat with Mr. Mehta, and I went and looked up the BIS also. It says it's 40-degree maximum ambient. I'd like to use the words. 40-degree maximum ambient, 24-hour average ambient is 30 degrees. So if I'm sitting at 40 degrees maximum, at night I hope to come down to 20, such that the 24-hour average is 30. Extrapolate that to today in Delhi or Rajasthan, where ambient is sitting at 50, I'm not going down to 10 degrees at night to give me my average of 30. So today something is already happening, either the will of God or how we are operating or factors of safety. Nothing is really caught fire. So this thing. But this is what the standards are saying. So whatever is 24-hour average has to be held at 30 degrees, which is what the equipment standards are being manufactured. And today, if there are OEMs, they'll say that's what we manufacture to. So you tell us differently, we'll manufacture to that. The second thing we are seeing is temperature swings. Normally, in most tropical countries, you see temperature swing of 8 to 10 degrees. But now we are seeing huge swings also. So it could very well be that as the load is creeping up, the temperature has crept up in the morning itself. And now you have to manage it. Or in the evenings, the winds may have died down, it doesn't cool, so your air conditioning loads comes on at night. So these issues are also playing a little bit of havoc with respect to input conditions, what I call input conditions. We are seeing far steeper ramps. People don't like the temperature, air conditioner on. Okay, so and those from Calcutta will tell you that how they can predict when the air conditioners come on when the temperature and humidity is high. Bombay will probably be one of them as well. So the human factor is saying, I don't care what the thing is, I am feeling hot, air conditioner on. And if you start tripping them because of other extraneous, they are not willing to put up with it. It is just, that's what it is. And then you have a steep, renewables are also having steep ramps, both on and off. Wind as well as solar. Solar has got a very high ramp, but anyway, the wind also has got a ramp. And then the time constants are long. See, this is where the issue is. Once equipment comes up to a higher temperature, it doesn't cool off in 1 minute and 2 minutes. It could be an hour before it cools off. It could be maybe an hour and a half, depending on the type of equipment, large transformers, small transformers, oil field, solid, etc., etc. So the question for the operator is, How do I know my thermal headroom? I've got a problem, the ambient is high, it's an afternoon, I've got the transformer sitting at 80% load, and now I've been told the forecast is going to be another 20% load. I should be able to tell, can I take this load, or do I not take this load, or I overload it for a short period of time? That's fine, So now you see how electrical measurements that was coming into SCADA and DMS, it may be nice to get a little bit of a thermal forecast into what is likely to happen from an ambient perspective, as well as from an operating equipment perspective. So that in the end, the thermal will also probably be one of the holders of the limits to have, not just current. Typically, we hold the current as our limits. But that may change going forward. So it's more of a question. And the second is, if the ramp rates are going to be high, Brazil, by the way, the ramp rates are very high in the morning. They don't have geysers. They all have induction heaters. Everyone comes on to take their bath. The morning ramp rate is almost vertical. So in our case, the ramp rate is not vertical, simply because we have 40-gallon heaters in Canada, hot water tanks. But in India, it's a 5-liter tank. So you have also a smaller thing. So the ramp must be pretty high in India relative to, let's say, Canada. So these are all issues that you have in managing the assets that people use in everyday life, that you have to then take it within the utility to say, how do I manage this? So the opening here is not that we have a panic. The opening here is a dialogue that will begin, and people will assess, is it a problem, not a problem, no big deal, or it could be a big deal going forward. So I'm going to start with each of the panelists and then get their views on this as well. So you want to use the podium or do you want to talk to me? So I'll get Mr. Mehta to speak first, and he will share his views on this subject.
Good morning to everybody. The subject we are discussing is a subject of concern, but is it a subject of immediate priority? Not necessarily from electricity distribution perspective. Let's look at that value chain of a power generation and consumer utilization. Who is contributing towards the climate change on a higher scale? Is the generator, because he uses the fossil fuel, which brings out your temperature variations, which brings out carbon and other gas release. Then we come to the transmission and distribution. Their activities are pretty similar. They contribute towards the temperature. Then we come to the consumer, who contributes towards temperature as well as towards the greenhouse gases or other gases. So if we limit ourselves to the distribution, the inherent contribution towards climate change by the distribution is purely temperature. And that is because of the release of temperature, which electrical energy converts into heat energy because of various situations, either because of the transformer or because of the natural dissipation of the heat. So if we restrict, I'm going to touch on a high level, then individual things can be touched by them. So what is required is to minimize the ambience increase of temperature by the distribution segment. What can be done? There are two things which can be done. One is you have an efficient equipment, and number two is where you manage your network which remains in a certain level of release of energy, heat energy. They sound very simple, but they're not as simple as they sound. It requires a lot of planning, it requires a lot of information flow, It requires a lot of data accumulation and use of that. Now, moderator very rightly said that, listen, the assets remain there for 40, 50 years or 30 years or 25 years. Even if we go by the regulator perspective, 25 years is a life cycle of a transformer. Now, for 25 years to gauge what would be the loading of the transformer over a period of time is not as simple, and therefore, there is no option but to keep developing the system and the network as and when the need requires. So the fundamental is network management, efficient management of the network, growth of the network at an appropriate time to maintain or to not contribute beyond a certain level of energy, heat into the climate, and be an added instrument in the so-called climate change. Okay, now we come to a situation where distribution company becomes a consequence management or a consequence manager. There is an impact by different agencies towards the climate change, but the impact comes on the distribution licensee because his assets and his activity gets impacted because of that. So what happens is, there's a flooding, nothing to do with the distribution company as a contributor. There is a substantial temperature increase, nothing to do with the distribution licensee, but it impacts directly on the running of the distribution system and managing the distribution system. The customer doesn't bother about whether it's your responsibility or somebody else's responsibility. He wants his electricity 24/7 as far as possible. Now, if we talk of the external environment impact, there are two kinds. One are those which are repetitive in nature, intensity may be different, and some are those which are unforeseen happenings. Now, the two have to be managed differently. You can prepare yourself for the repetitive nature, but not necessarily you will be prepared for the one-time happening. And just to mention that, I would say in 2005, we had a cloudburst in Mumbai, and it was one happening in 100 years. Nobody could predict, nobody was ready for it, and we had to struggle for first 2 or 3 days to rejuvenate ourselves from normal activity, normal management into that excessive management. So that's one thing which every distribution company has to keep in mind. You can draw out as many disaster management plan, but not necessarily all happenings would be sustained through that management. What can be done? One is, there's a lot of information available compared to what used to be in the past. You have weather forecast, you have various available of information which impacts a geographical location and consequence of causing a different environment in that place. So what one need to do, and I think Discoms are way behind in that, is assimilation of these information on a regular basis and review that with reference to the impact on your own activity. I see a bright potential of artificial intelligence and machine learning which can be very useful if effectively used in this direction. I think it is not being used substantially, or I would even say at all. So that's one thing. Are we ready? We are ready for the normal happenings. We are not ready for the abnormal happenings. We are not ready for more accurate predictability. Now, this is a triangle which I put forward to you from the Discom perspective. What happens typically is that when there's a climate change, your capacity utilization of asset enhances, speeds up. Therefore, again, what I said earlier, you have to periodically review and manage your assets either by increasing the asset or demand side management, whatever name you call it. The point is, asset has a capacity, keep the asset in capacity, do everything else to do that. Now, this broadly covers the broad aspect of what the climate change and distribution has a relationship. I think I'll leave it at that, and then we can answer the questions as and when required. Thank you.
Mr. Sitawati has put very forward-looking questions to all of us. But I must agree that we should think about it way ahead of time. That's pretty important. Because when you talk about this very topic of climate change, we still have divided thoughts, whether it's therefore real or not. So while one of the effect is the kind of cyclones which we face, I think this is today's news. There is a low pressure, and we are going to have a likelihood of cyclone in our coastal area in Odisha. So there is no doubt that it is not going to happen. Or when you look at this table, in the last 5 years, there has been average 2 to 3 cyclones every year, which was not the case if you travel a decade back or 2 decades back. So that being the reality, I think the most important question is how does one make, or how does one go about advocating in terms of making every stakeholder realize that we need to work upon it. And we are one distribution company, whether it's Odisha, it's West Bengal, it's Andhra Pradesh, to a large extent Gujarat, and then of course to some extent coming down to Tamil Nadu is I would see as the affected people. So how does the regulator looks at it, how does the government look at it, and how does the distribution company is allowed to focus on this part of it. So here climate change has a role to play because the kind of, even if you take the rainfall part of it, which Mr. Mehta said, what happened in 2005, a cloud burst in 8 hours time, and you have a high tide level, and then all water pouring across the city, everything getting choked up, and you need to react to that situation once in a blue moon sort of a thing. But then, whether it's temperature change, whether it's a high flood, whether it's a cyclone, the super cyclone which we faced in Odisha, when we look at it in 1999, that was one of its kind. We faced at 300 kilometers per hour. But then the choice is left to us whether to design it for that or not. So if one looks at hydro power plants and one goes to the design of the dams are designed for once in 1,000 years rainfall. But that's how it is, because there can be a cloud burst, and if the dam bursts, the damage is going to be pretty high, unimaginable. So you need to design for that, and if your dam sizes are big, you better will design for that. So I come from an organization which started the journey with hydropower plants, and it has a flood management situation in place. It understands what are the rainfall for the last 150 years. So we have a data of 110 years, we have the past data of the rainfall, and when you design a hydropower plant and the dam, you minimum require a 30 years data to design the dam itself. So obviously, data makes a big difference in terms of how do we structure our planning, but it is very critical in some parts of it. But how much do you apply for it in different perspective, we need to take a call on that. So I would share some thoughts on it. So one is, as we take the journey of facing the different cyclones way ahead, the risk is pretty high on a Discom. In terms of seeing that, obviously, it's Tata Power who's distributing power, so the expectations are pretty high. Once the cyclone goes, the power needs to be restored is one part of the expectations. There are issues, and one goes to US even today, and if there is a severe cyclone, or one goes to Japan if there is a severe cyclone, which they had some times back, depending on the intensity ranging from 100 kilometers to 300 kilometers, the damage is going to be similar if the network design is almost same, and one cannot come away with it. So restoration time is something which will affect the customer in terms of 24/7 supply. As a Discom, it definitely affects the revenue part of it. So how does one match both the customer as well as the income of the Discom? One needs to make a balance of it. And third, in terms of how do we structure the expenditure over a period of time. So in this journey, while we have been here for the last 2.5 years, one of the first risks we identified as a company was cyclone management or the disaster management part of it. And whatever we plan to do in terms of designing our network, a DMP is a must for any such situation where one really looks at how, when there's a fire, you need to quench it at any cost. And that's the first thing you need to do before anything else happens. A cyclone can really make life difficult in many ways. So obviously, if you have a DMP in place, it makes life easy for everyone in terms of what best you can do at that point of time. So we have a DMP in place, and to structure it, it needs to go through a typical checklist so that one doesn't have to go through again and again except for the learnings part of it. But today I can say, when we have designed our DMP into different levels, level 1, 2, 3, depending on the intensity of the cyclone, it's one push of a button and the organization is seamlessly ready. You don't have to run through any process. It's like a firefighting situation, and your firefighting equipment is all ready to meet the situation. Now, in this situation, typically men and material play a critical role in terms of how do you address the situation. But there are innovations which one can do, and prioritization one can do so that life is still attended normally. In terms of seeing some of the critical installations, how do you ensure that they have an N-1 or they have a DG set, or you see that there's a mobile substations. Like we have created almost 8 mobile substations that you can go and attend any of these critical situations. And how do you use modern tools to see that even a tree cutting exercise is done very efficiently before and even if required after it. And thanks to the government support in Odisha, that makes life still more easier. So because when a cyclone comes, even the roads are blocked. So if the government machinery is there to support you, the roads are cleared in time, because that itself becomes a hurdle to reach the site. So the DMP is not only taken by the Discom, but even by the city, by the district, as well as by the state itself. Then it becomes a seamless exercise to go about it, and that requires some level of commitment by all the stakeholders. In the DMP, one more aspect is how do you even manage the space part of it so that you are able to meet some of these real high-level wind intensity cyclone. And then how do you really plan for the disaster resilient network? And when we looked at it, and when we really wanted to go about building a disaster resilient network, it was more than a 1.5 year exercise. And whether you are really expecting a high temperature rise in the coming days and you want to build something for that, both have similar effects in terms of the costing, in terms of the capex part of it. So we went about different stages. Quickly, what one needs to see is what kind of wind speed. As I said, on rainfall, now it's about the wind speed. In our case, we can face a maximum around even 300 kilometers per hour, which we faced in 1999. So if that be the anchor point, then you keep thinking, how do you design various aspects? Now, that's a huge cost, which is going to be there for the organization. And then you structure your entire planning. What can get more affected from the coastal area to the inner part of it. So your design can vary. The first 20 kilometers, then the 20 to 60 kilometers, and above 60 kilometers as the damage goes by, you can structure your entire design part of it. That's how we have been trying to do it. And we have involved, the central government has participated in it. We have involved even the regulatory framework to sensitize how we are working on it. So in this journey, what we have said to ourselves is, if we want to build a disaster resilient network, it's going to take at least a decade plus, more than 10 years, in a very systematic way. But it's worth investing it so that even after 10 years, if we can say that we can bear a cyclone which is 300 kilometers per hour, it's a great achievement. So at that point of time, the power requirement is going to be high. So whether it's a mobile which is required day in, day out, or to other accessories which we require. So that time our reliability has to be very high. Keeping that in mind, one of the strategy which we have approached is to see that we have adequate space for any emergency for 300 kilometers per hour. And that, there are different innovative approaches we have taken there. And one of them was to see that can we put CESC, a disaster cyclone CESC or a disaster management CESC, wherein you just charge around 2 paise to the customer. And that will give you some amount of funds over there every year, and you try to maintain that as a space to build your network part of it. But over a period of time, it works out pretty well. So different models we have worked on the space part of it. Government of Odisha is also supporting us, having discussed this part of it. Right now, we have been given around 50 crores to do the space management, but it will be a rolling space so that it doesn't get wasted as well. You use it and reuse it and pump it back every year. So this approach at least can help that there is no customer burden. At the same time, your network is getting built up. Again there, the next question is how do you reduce the cost part of it? And if you see the different components over there, main which comes is the poles part of it. So we worked on the poles as well. The present pole, when we saw the costs were pretty high. So the team came up with different concepts, thinking about it. And what we eventually came up was, which is there in the display as well. And that brought down the cost by almost 40%. It's in the pilot mode. We have installed 15 of them, but in the next 5 years, we have planned for a long rollout part of it. And there is still work to do on that. And the idea is to see how we can even have prefabricated foundations so that even that can be done during a cyclone in a much more faster way. And the approach is to see how do I strategize between urban and the rural part of it, so that in some of the urban or semi-urban area, I do have underground cabling as well, which is again a very expensive part of it, but in some smaller towns, you still need to do that. In our case, for example, it's Puri, which we have already done, thanks to the support we have had from the government there as well. Over the last 10 years, it has been slowly built, and as we end this financial year, the entire Puri will be having an underground network as well. So it has to be phased, and one needs to prioritize these aspects and go ahead. So there is a lot of design aspect which one needs to continuously work upon and see how do we really bring down the cost, which is likely. And if this RLP is used by all the Discoms, I expect the price to go further, which can make it much more easier as well. So in short, I think as we get ready to face the cyclones in the coming days, while we have a DMP in place, we have a future plan in place to see that we do not increase the tariff, but at the same time build a disaster resilient network. It's for us to continuously work and see how do we really bring down the cost with a lot of prioritization in place. And flood, if I look at that separately, this year, instead of cyclone, we face floods. And flood is, as Mr. Mehta said, it's going to be there. Not because the whole season will be of a good rainfall, but in terms of one particular day or one particular week, you may have a high intensity rainfall part of it. So how does one get ready for that? So when I look back even in 2005, when we faced the high flood level, on that day, although our network was very less in terms of the retail distribution in Mumbai, what I still observed was, except for one substation, all the substations of Tata Power was still feeding the customers 24/7, even at that intensity of rainfall. And the only major design change there was, every substation we had put was above the HFL. So we knew what is the high flood level in that place, and you go about designing that. So this is one of the key areas. So as we looked at, we have mapped all our DSs and our primary substations. We still have some of them below the high flood level. So obviously we know there is a challenge over there. So you go about countermeasures of keeping the dewatering pumps, etc. But we need to look at how do we come out of this so that on a long-term basis, all your, at least the substations are above the HFL part of it. Having done that, I think even your distributing substations, which especially when we have more rivers in this part of the world, how do you, over a period of time, lift with a plinth? There's some strategy which we'll have to use it, so that at least the critical ones, the priority ones, year after year you prioritize and lift that part of it. Apart from your DMP, to see that one still attends to some of these challenges when we face in the coming days. And technology is something which we can continuously use. So we are using GIS at this point of time. We have mapped most of our networks and the geography as well. So that helps in terms of understanding, even when a high flood level happens, what are the substation gets affected, or if there's a cyclone, which part of it gets affected, which section needs to be ready, VEMA material needs to be ready. That is done much more systematically and accurately as well. So technology does become an enabler here. So the other topic which is something new to all of us, and we are working on it. I think this is an area where is typical to many such challenges we face. One of that is, if you want to buy a meter and you want to have global participants, you typically find global participants giving meters, especially to either Reliance or Tata Power in India, a challenging one. Because over the years, what we have done is we have worked on anti-theft measures, and there are a lot of anti-theft measures built in the meter. So one needs to actually get ready to supply that meter for us, which is not the case when you buy it from a European country or other parts of the world. So the designs has evolved over a period of time. So today, when you buy a meter in India, we try to see that it works to our specifications. Similarly, the way we have worked in the last few years, if you take our transformers, we design it actually for 50 degrees. So it's part of our specs, it's part of our procurement design itself. And the manufacturer has to get ready for that. So obviously the ambient design is 40 degrees, but we say it has to be for 50 degrees. So one can, the transformer suppliers do have challenge in terms of giving transformers to us, but they need to go through those type tests and still ensure that we do it. But again, the cost part of it, one needs to work it out. But then given the Indian climatic conditions, I think 50 degrees is a norm which we'll have to set for ourselves, and there is no way about it. I think that's, I think it's, okay, yeah, I will leave it at that. So it's more for us to structure our own design in terms of how do we put our manufacturers and OEMs to see that it needs to be worked out over the time. When I look at hydropower plants which we bought way back in the 1920s, today there is a plant which was commissioned in 1927. We are in 2022, 95 years. The penstock, that's the pipe, and the turbine and generator, while it has been overhauled over the last 95 years, they are still working. So whatever conceptualization was done at that point of time, just imagine penstock life is designed for 35 years. But the way it was done in those years, it has lived for 95 years. And those are riveted penstocks, not even welded penstocks. So you can imagine the design aspect which has gone to it, but then it's given much more than what one can expect. And today we generate power at 1 rupee 50 paise there. When I joined Tata Power, we used to generate power at 6 paise because everything was depreciated at that point of time. We rebuilt it, but still the equipment is working. The generator, the turbine is still working, giving you an efficiency of more than 91% plus. So that part of the design aspect, I think, does help in terms of conceptualizing and seeing the long-term perspective. Thank you. Very much.
Good afternoon, ladies and gentlemen, and all forum participants. Thank you, Mr. Radian, for the opportunity for us to share experience, and also I got a lot of knowledge and experience for all the participants during this 2 days. This is my first time to India, Mr. Reggie. Thank you. And we are also in, let me share directly to overview of PLN. PLN is state-owned electricity company that integration between from generation to retail. And I am in distribution department. And in Indonesia, PLN is the only company, state-owned company, who operate the utility electricity. But government give permission to 49 company, private company, which operate the utility in a certain area, from generation to retail. For example, in industrial park, in close to Jakarta, capital city of Indonesia, there is two industrial park. Oh, sorry. There are two industrial park that private company operate the utility. That, for example. And you see in Indonesia, almost 2 million kilometers square with 23% water area, 76% is land area. There are almost 17,000 islands, which 10,000 is inhabited. The most inhabited island is in Java. This is Java, more than 100 million, almost 150 million. But there is a small island in the border of Philippines, in the north of Indonesia, inhabited less than 50 houses. But still, PLN should supply electricity, provide electricity on that island. Indonesia is 64,000 kilometers, and there are 34 provinces or states, and there is 84 more thousand villages, and there is still 6,000 villages that we cannot supply electricity. And in the next 2 years, we have to supply to this 6,000 more villages. It's very challenging because in the mountain, in the small island, rural area, no population in Indonesia more than 270 million. Okay, let's continue. I continue. Now, in 2022, the peak load is more than 45 megawatt. It means in 2021 to 2022, there is more than about 3 gigawatt peak load, totally. And the transmission line, about 64,000 kilometer circuit, power transmission 2,200 more unit, medium voltage distribution line 400 to 23,000 kilometer, low voltage distribution line 598,000 more kilometer circuit. Customer 82 million customer, and energy challenge 57 terawatt hour. Yeah, our topic is about national disaster statistic. You can see in this table that the disaster trend between 2007 to 2021 is increasing. Sorry that in this table, 2021 is not fully data, maybe almost twice than this table. So every year, Mr. Nevi, the disaster is always growing up. Yeah. And the number of disaster mostly happen in Java Island, which the customer is mostly in Java Island. That is our challenge. And the impact to our company is that the number of disaster is increased, duration of outage also increase, and the energy not served also increase. And so our management make a disaster life cycle, that mitigation, disaster preparedness, disaster response, and disaster recovery. Let me tell you something, that there are four points that PLN respond to the disaster. First, to build a task force team. Task force team member is from PLN technician, government officer, army, and police, where each of member have a capability. For example, for army member, usually from division of construction. In the Army military, there's a division construction that have capability to deploy the force, the team, the personnel, as quickly as possible. And for government, there are a Ministry of Public Utility that have and can deploy heavy equipment in the quick as possible. And there are equipment that stock in certain area that disaster happen. And also from police, because usually when the disaster happen, when the PLN technician sent to the disaster location, the security of technician should be guaranteed. Why? Because in the disaster, usually the people crazy, people, everything. Yeah, that's the point. And then we also have a disaster center organization. Before to disaster center organization, we have InSafe software, where it is free and open source software that developed by Indonesian government and Australian government and supported by World Bank. This InSafe and GIS utility mapping integration is a project that produce realistic natural hazard, flood, earthquake, tsunami, landslide, wildfire. Every year in a certain area, Kalimantan and Sumatra, always happen wildfire. Abrasion, volcanic eruption, and impact scenario for better planning and preparedness and response activity. It's very helpful for us to mitigate, to prepare, and to quick respond, because it is integrated between the distribution network configuration and the natural hazard. And we also built a distribution network configuration and control. What is distribution network configuration and control is that this is integrated between disaster recovery system, DRS, substation, and distribution control center. It is supported also by SCADA, by AMI system, and other tools. And this is the organization of disaster recovery system. In the Advanced Control Center, there is a national control center, which is the control of high voltage transmission, and regional control center will control 150 kilovolt transmission. And this distribution control center is responsible to monitor 20 kV. And there is also this disaster recovery center. This distribution control center, there are 22 and scattered in the area of Indonesia, and now we are planning for next 15 DRC. This is how we change the defense system scheme transformation. Previously, we have a static defense scheme. it is static target, just use the existing defense scheme where the actual load is dynamic. And with the dynamic adaptive or adaptive defense scheme, the load shedding is calculated and executed in real time. And there are 8 points in the adaptive or dynamic defense system. Okay, this is in each of distribution system. There is a fault location, insulation, and service restoration. So when there is a disaster, DCC control can make a distribution simulation. So they can reduce the impact to customer as much as possible. For, in this FLESR application, there's a application can reduce the number of customer impact by fault, by automatically isolating and trouble area and restoring service to remaining customer by transferring them to adjacent circuit. It means that as in PLN there is no distribution private company, all by PLN, so it's make it as easier to make a distribution simulation when the disaster is happen. The fault insulation feature of technology can help crew locate the trouble spot more quickly, resulting in shorter outage duration for the customer impact by faulted section and the reduced number of customer interrupted and the associated customer minute of interruption and the primary measure benefit of technology. There are 15 distribution control center ready for FLISR and 7 in planning. So in a certain area, for VIP area, we built a zero downtime network configuration. It is for a high priority service area like tourism area, VIP tourism area, like in Bali, Lombok, Labuan Bajo, Komodo Island. This is a medium fault network topology, which this is parallel and closed loop. The closed loop is very helpful for quick response or quick normal system, because you see in this configuration that in the left one, this before the spindle, and then in the right one is the closed loop. When there is a power interruption in some area, so this area that can supply with other loop. That's the idea. And to make it this is work properly, so the K is communication network. There is a redundant fiber optic, 2 for protection communication link and SCADA communication link. And protection system, there is a main protection system and there is a backup protection system. And also it's equipped by early warning system. This is the early warning system at medium fault cubicle. There's a telecommunication panel, there's RTU and protection panel and control. Oh, say, yeah. This is the early warning system that we built in medium faulted cubicle. There is a telecommunication panel, RTU and protection panel, and control processes. And this can detect thermal, arcs, temperature, humidity, and smoke and flood. So this is the early warning and directly DCC center send notification to disaster center. So how about the response and recovery? This is outage management system that we have a dashboard, a single source data for all the condition. In the dashboard, we can manage outage. We can in live monitor how many customer that impact and how many substation. For example, in this case, there are 37 that not already normal, and 68 has finished normally. And we have a mobile PLN. Mobile PLN is application that customer instantly have notification from PLN what happened in this area, what happened and what PLN doing in the field. And from this application, PLN Mobile, customer can ask PLN disaster center how long the electricity will be normal. This PLN Mobile is, we call it super application, super mobile, because with this application, customer can buy token or energy, can have a temporary supply and everything. And for disaster management, PLN Mobile is very useful, because when there are a complaint by a customer via WhatsApp or Instagram or everything, we record it. And then the disaster center can blast the information. Yeah, last 2 years, PLN intensively developed digitalization in its sector, especially in customer services. So that's why we PLN achieved Digital Innovation Award 2022. Yes, it is just a picture how we respond and recovery the disaster, like a flood, landslide. And this is, for example, when in Jakarta, capital city of Indonesia, there is a flood, big flood usually in end of year. We can monitor live in this dashboard in head office of Jakarta. How many substation has normal, how many not normal, how many customer we can monitor, we can see it in this dashboard. And the important thing is that PLN, to recover the disaster, have agreement with the manufacturer of material like pool, draft and everything, that the agreement is signed a year before. For example, in the end of this 2020, usually we sign agreement with manufacturer that PLN need in the next year. And all the manufacturer is all over Indonesia, scattered in Indonesia. So all the manufacturer is appointed, its manufacturers appointed where their area, when the disaster happened, they have supplied the material. Yeah, I think that's all that I can share with you. Thank you very much.
Morning, good afternoon. Thanks to ISGF for the opportunity. Most of the speakers who have been speaking over the previous session as well as in this session are all from the utility background. I come from I would say the EPC background, where we install new assets and design as per what our Tata Power gentleman was mentioning about what we need to specify. But slightly taking a larger picture, we can classify the impact of climate change into broadly three categories. One is temperature, another can be flooding, and third is wind. If we look at these three, probably we have a very clear demarcation with wind zone mapping available in India, which of course needs constant updating. We can use the specifications to suit the particular state or particular Discom, rather than having one standard fit all. Similarly, we have, even for corrosion protection, we have standards available which tells us where higher corrosion is expected and where lower corrosion is expected. We have some standards available. Similarly, for temperature, if we are able to work on together as a collective, where we need to specify higher ambient temperatures and where we need to maintain what we have today as 40 degrees maximum ambient. Some places even 50 may not be sufficient. In fact, our experience of working in the Middle East is some of the temperatures can be even 55 and very rare cases even 60. So it becomes important that we classify the requirements more clearly so that one size or one specification fits all can be moved away from. Second is, I would believe that whatever assets we do have today, that's one of the questions the chair had raised, what do we do with that, how do we manage it better? Today I feel that digital tools with IoTs is opening up possibilities where the assets like the distribution transformers, which have no other connection, can be still monitored with a few IoT add-ons. Probably if the Discoms can take a step forward in terms of specifying or at least having some facilities to have these IoTs installed, either in the existing assets or the new ones coming, then a better understanding of the assets, how they are performing, will be available. Similarly, we have the possibility of evaluating a lifetime or life cycle availability for an equipment. In the IEC, where as an example I am taking, there is a cyclic loading concept where you can design the transformer if it is going to be loaded in parts of the day or parts of the year, but some other parts of the day or the year you are going to have a lesser loading. You can obviously work out a cyclic loading thing and determine a more optimum solution for a transformer sizing. Now, having standardized the distribution transformers or the transformers which the utilities are using, the same concept can be used if the data is available from the usage. If the climate change is going to come with an additional temperature increase of 2 degrees, 3 degrees or 5 degrees, whatever be the case, is the asset going to be better utilized for us, or is it having a threat? Can be definitely established, which means the various systems that have been talked about previously, yesterday and today also in the first session, how much of that can be used to really get to the health and wealth of the assets, and how do we manage those assets better for a better output is definite possibility today with all the digital tools that are emerging in the field. In terms of the assets that we have to install, there are a few possibilities which I thought I'll put forward for the larger consumption and thought process. One, in the renewable, if we go for the utility scale renewable solar, we do install meters, we do install instruments which measure the radiation of the sun on a regular basis, on which all the protection generation guarantees are all reworked continuously. Now, can we install similar temperature measuring or the wind zone closer to the Discom operating areas, where they will have a better understanding and predict the vulnerability? These are not very expensive. I am sure these can be put together to see where the vulnerability for the Discom is likely to be. Second is where you have winds like our Tata Power MD was mentioning, if we have clear classification in terms of closer to the, let's say, sea and going inward, can we have differential wind speed calculations to have the protection on the assets better? More importantly, whatever new assets that are being created, is it possible to look at it more holistically from a lifetime availability perspective, ability to service the customers on a higher availability, look at the specifications to be more tuned towards water flow. Most of our cities get flooded, one reason or the other. I'm sure we'll work our way through that as a society in some time to come, but the reality what we face is most of the cities do get flooded. So how do we protect our assets? Do we raise them, or do we come up with higher stringent specifications in terms of the equipment which are suitable for outdoor? Yes, there will be more cost involved in the asset creation, but the longer time objective of a better and continued availability of power, because the new generation, as what the minister was mentioning yesterday, and the new type of loads what we are going to feed over the coming years are going to be more of 24/7. I think the people or the consumers are going to expect that sort of service, which means our availability also should be that high. So in summary, there are tools possible to look at for installing even on the existing assets, to monitor them and use them better, and create more specific area-specific specifications for creating the new assets which can give us a better protection against the climate change which is being talked about, which even if it happens or doesn't happen gives us a better understanding and better readiness to deal with. On the recovery part and disaster management, I think the experts have already spoken, where I have very little to, I would say, add on. And thanks for the opportunity. I'm sure we have a lot to work on. Thank you.
By the panelists, and Reggie, you got more work to do in your future sessions to put on. I think there were several messages that they sent, and I thought I'll just summarize before we open it up to question. The first is the notion of help in recovery. What do we do in North America actually is, we pool our own people as insurance for each other. It is very common that Canada will send over 15 to 20 trucks with people whenever Florida has got a problem. And so this is our own, we call it the Japanese word kairatsu, where we are self-insuring ourselves for the human resource part, even though the recovery may be or may not be funded by emergency funds. So that is one. It's a very important. Second is pool. I remember when at Ontario Hydro, we being the mother utility in that area, we used to keep transformer spares and mobile spares for the smaller utilities because they could not afford to keep spares. So we would always at CMS Pickering, we would have 8 or 9 mobiles that we will keep ready to roll. And this was just like a big brother or a big sister helping the younger person. Because these are long lead items, you just can't replace them while the customer is without power, especially in the winter. The second part is the notion of how quickly it will come and how do we prepare. What we are finding is a 100-year floodplain, which is our assumption for locating substations and generating stations, is being violated every 5 years. So we are now looking at 200-year floodplains. And 200-year floodplains, first of all, we have no data because it was never started in the first place. And second is, what do we do with all our assets that's already sitting in the 100-year floodplain? I mean, can we just move it up? We cannot. So I think to some extent, Shadbhaga mentioned about the mitigation and the flash flooding that comes in. And so you may have to take certain corrective measures around the property to see that these things don't occur, flooding doesn't occur and things like that. In Calcutta, I believe on the distribution transformer that's sitting in the pavement, they have put actually a kind of a water sensor. The moment it senses water, it trips the distribution transformer so that nobody gets electrocuted. So we have these small things, call it jugaad, but it works. And so it's an important one. On the flooding, in Canada we had one. When I was in the utility, we had a large substation, 500 kV substation flooded. And 3 kilometers away was an equally big one by the airport, not a single drop of water. And so from that year on, in fact, in operations, what I did was, we would not calculate flood based on 10 square kilometers, which is the practice we do, or even Environment Canada gives us data. We forced them to give it on a 2 square kilometer area. So we call it the mesoscale. And the mesoscale plan is what we would apply across our assets to see whether we really need to concentrate even more efforts in a particular area, and so that if that ever gets hammered, then we are there to protect it. In the ice storm that took place in 1999, in fact, we lost transmission towers. I mean, you have floodplains, we have ice storms that take away, a lot of our assets in the winter. So our care with respect to quick restorations is far, far more important because lives are at stake at -20, -30. Without electrical power, you got a huge problem. City of Toronto, we had one in 2008 or 9, where for 11 days we did not have, because all the trees fell off, all the distribution lines were all snapping like, twigs. And it took quite some time for the police, the military, as he says, to come and take it away from smaller streets as well. So there was a big concerted effort to bring diesel generators on. All our malls were actually fed by diesels. And people would go there not only for their meals, but to charge their telephones. It was such an orderly way that 45 minutes was given to every family to go and charge their mobiles. Because as he said, on Twitter I would get what is happening to my street that day and when can I expect the power supply to come back. And so the communications was still on with respect to mobile communication. So I was able to sort of relate to some of those things. The question is equipment about the future OEMs. There were mentions of 50, 55, 60. Who knows where it is. The question is, can the OEMs, I don't know how many OEMs are here, can you build a mousetrap better using different material than say paper insulation, which has got a temperature rise of only 90? Regular oil, I see that Ram Pillai is not here. He went to the Estafel transformers when he used to be in Bombay. They have a much higher temperature. So the temperature rise is not 120 degrees on the top oil. You could actually get far higher if you go to ester fill. So Brazil has gone to ester fill transformers because of the ability to take a higher temperature rise. So things like that could be done, and of course the different designs. Talking of solar, you know how many solar plants were lost in the various winds that took place? Puerto Rico has been hammered every 3 years. And what they find is that that solar panel doesn't stand a chance with those kind of high winds. So while you're talking of renewables and 30 gigawatts and 130 gigawatts, just be aware that you have to design it in a way that even when automatic, you know, that when it goes flat, when you have high winds, you take it flat. But even then they have a problem. So what has been done in Puerto Rico, 35% of the baseline solar is actually flat on the ground, so that it has no chance of ever being ripped out. And that becomes the baseline for a restoration should everything really go wrong. So some things to learn from. What really got me, and I'll end with that, is the battery standard. Do you know what it is? It's 25 degrees. The actual solar panel standard is 25 degrees. So all of you who are putting solar panels should know what is your derating, even for 40-degree ambient and 50-degree ambient, let alone operating temperatures, which is 65. In fact, in the Middle East, he works a lot in the Middle East. And it's amazing how if you were to actually map the temperature below the solar backsheet, you are sitting at a very high temperature. In Calcutta, where Reggie has done projects, and I was glad to help him there, the under the hood temperature on a hot day can be as high as 60, 62 degrees. So now your battery capability on the electrolyte is getting shorter and shorter and shorter. And yet people are just making an assumption that they can use what the standard says. The standard is only what the manufacturer has designed it to. You as utility folks have got to know how to apply it to their practical applications. Mr. Srinivasan talked of IoT. In fact, the guru of IoT is L&T stuff. Every construction equipment, I mean, that's the CEO's mantra that he has got it to everybody, is all IoT enabled. So every bucket truck, whatever assets they have, they know exactly where it is, what's the capability. We in Canada did that, in fact, for disaster management from 2004, where every bucket truck mapped to GIS knew bucket truck A only can fit that, bucket truck B only can fit this, so that the asset also is not misplaced. You could be ready with a disaster management plan, but then you got the wrong people at the wrong equipment sitting in the wrong place. So to that extent, we had got done, the emergency preparedness. So I think there are lots to learn, and we need to share far more. I mean, he talked of the ultimate of smart grid. In fact, his solution is smart grid, OMS, Flusser. How do you reduce and isolate all these customers so that only the minimal outages take place? He talks of double ring systems for the various areas of tourism, for example, so that business is not lost. Right? I had a chance to visit Indonesia, thanks to Reggie many times, and then to Denpasar. I spent time in Denpasar, Bali. You have to sometimes ask these questions to find out how beautifully they have differentiated in their thoughts, relative to some other people. So I think we need to really exchange information going forward. So what I'm going to do now is I'm going to open it up for questions. Direct your questions to whoever you wish to. And if not, if it's a general question, feel free, and then we'll start with that. Yes, I see one hand there. If there are mics, can go there, it'll be good.
I'm Rahul Kumar from Tata Power, Western Odisha Distribution Limited. Actually, earlier I was in CODL. In the year 21 May, we learned from YAS that disaster management as a disaster planning. Now what we do, we identified 30 critical items which will help immediately to restore the power. Now what we do that we take the stock from all the 4 Discoms, compile it, and we circulate that IMIS by 10th of every month. So it gives a clear picture. In case there is a disaster, the Discom will know where the materials are available and it can be easily transferred or helped. Thank you.
Thank you. Good. Very, very good point. Very good point. Yeah.
I'm Vice Admiral A.K. Saxena, retired from the Indian Navy. And I thought I should share some of my views specifically related to Navy and then relate to the conversation that is taking place here. It is well known and everybody appreciates that climate change is causing difficulties for the equipment, and we must not shy away from there. And recognizing this fact, when we were designing some of our warships a few years back, in fact about 5 or 6 years back, we realized that the seawater temperature intake for the air conditioning and refrigeration plants is specified as 35 degrees. So we raised it to 40 degrees as our tender specification. And we were shocked to know that the cost of such a design was almost 35 to 40% more than what was the normal 35 degrees AC plant. One method was that we pay that cost, but then the problem was that there were hardly any vendors who were ready to supply that, and therefore we would have stuck into a single vendor situation. Fortunately, in ships, warships especially, we have spatial as well as capacity redundancy. So we decided that instead of going in for higher specifications, we use the existing specifications and use the capacity redundancy at the time when there is a requirement, when the temperatures are really higher than 30 degrees, 35 degrees. I am talking about the seawater temperature. So taking a cue from here, I would recommend that possibly there are two solutions. One is there is no going back, that there will be a requirement to derate our existing equipment as and when there are temperatures which are higher than what is specified, and this decision could be taken intelligently, as Mr. Mehta mentioned, use of AI, IoT sensors and so on and so forth. The second is that we need to, whenever we are replacing our equipment, we replace it with much higher capacity, because here we have to take into account the growth requirements of our particular sector or a particular equipment, and therefore we use the additional capacity to overcome the problem of higher temperatures. I think that would be an easier solution that will kill two birds with one stone, in the sense that whenever there is a requirement of higher capacities at a later date, this will cater for it, and whenever there is a higher temperature rise, we cater for because of the available existing capacity which was enhanced at the time of procurement. These were my views.
Thank you. Any comments, questions?
I will just respond to your point. If you go really by what is stated as a standard, it all requires N-1 capacity. So it's already provided for, but there is a cost attached to it, and there is a consistent, that has to be passed on to the consumers. And that's where the barrier starts between the regulator, Discom, consumers and everybody. Otherwise the standard is N-1 capacity requirement.
Yeah, actually in our Canadian practice, we have the dual-ended spot network, exactly too, where we put two transformers coming off two lines, but these are large transmission substations, such that we would have a one-to-one backup for recovery in case a transformer goes down. But on the distribution side, since we don't have a 1:1 backup, our overrating on the transformer actually can go up to 135% on the load for about 4 hours. That just gives us enough time to rebalance the load somewhere, because they're all mechanical at that point. They're not very, very automated in rural. And then we try to bring it down over time. But I think the point you're saying is valid. By the way, he has designed some of the largest microgrids on record here in this room. So later on you should get to speak to him. Every ship, every aircraft carrier is a huge microgrid. And he has gone through all that. Submarine. So yesterday I had a great time understanding and learning from him how he designs things. A power engineer, by the way. So thank you, Admiral. Any other question? Yes, there's a person right at the back.
Sir, namaskar. I am Shubhadeep Rajadhre, Tata Power Delhi Distribution Limited. One issue which comes up every time we go in for factor of designing is...
Speak up, speak up.
Am I not audible, sir? Is it fine now? Right. The thing is, what is factor of safety and what is factor of ignorance? This is one thing which comes in. And the second point, which is becoming manner in which we are working is, that is, we are taking requests from across the nation and trying to have one order so that the large scale costs come down. But the ambience and the temperatures and the climatic conditions across this huge subcontinent of a nation that we have is largely different. Now, going by what you have said, understood, the thing is, there is no list of materials that a distribution utility needs to maintain which will have a higher factor of safety and which cannot be conglomerated. Is it available in the US, as you were saying?
Okay, I'll first let the panel answer your question with respect to India, and then I'll give you whatever I think. Any answer to
Thank you, sir.
The diversity of equipment, the diversity of temperatures, he believes there's no one standard.
You're very right. The diversity, forget India, anywhere. The territorial diversity will always be there, and there will always be variation because of the territorial diversity. Now, the point is, the distribution utility can give only its own perspective. Now, who is to consolidate? It's impossible that the distribution utilities would give you a consolidated number. So it is the responsibility of the manufacturer of the equipment to find out what is the diversity of requirement, and then decide how to manage that. Utility can only give you for that particular utility, not beyond that. And there's nothing, no agency which consolidates the requirement of all the utilities to give you that this is the diversity which is required for an equipment. So manufacturer has to work on his market.
Anybody else?
Just to add on to what you mentioned, most of the manufacturers do have a range of equipment, whether it is 30, 40 or 50. And as you say, if the requirements are known for different utilities, they would be able to provide the right equipment. Obviously, there is a cost impact, but definitely I don't think up to 45, 50 degrees there is a depth of design as such. Maybe 55, 60, yes, there could be some special considerations that the manufacturers in India may have to adjust to, but up to 50 I don't see a real problem in giving different, if there is a real differentiation in the materials they use. That also is the case, like if we specify 50, cost may be quoted higher, but in essence it may be the same equipment. So this is something manufacturers always have the flexibility to deal with.
Yeah, you see, your question is valid. Now, how do we do it there, right? The southern part of United States is warm. The northern part of Canada and North America is cold. Even within the United States, we have different, flood conditions, rain conditions, snow, temperature, everything. But there is one element that was eluded here in the answer, and that is we have the Canadian Electrical Association, the NERC. The associations hold the feet to the fire in the standards. I sit on the Canadian Standards Association for batteries. And I can tell you that even though each of the utilities may have different requirements, we force something towards a common where the mass merchandise of manufacturing can lower the cost as well. So maybe that's something ISGF should take over, is to look at what the variety is, and that variety then becomes to the extent standardized. Now, can it be standardized all the time? No. In my own utility, I have a BIL, a higher BIL in the north, a lower BIL in the south. Because the Ferranti effect at 150, nobody has seen Ferranti, I have seen Ferranti, where the sending end voltage is lower than the receiving end voltage, because such long 115 kV lines are taking. So we have two sets of BILs, And therefore, that becomes our internal standard. But notwithstanding all that, we should try our best to have a set that hopefully everybody adopts. Now, when we adopt a standard, but one utility may buy, one utility will not buy, third will say too expensive. That is where we come together and say it's okay if it's a little expensive, but the mass manufacturer to those commonalities will also reduce prices for everybody. So maybe we come together a little more often to address some of these diversity issues. Perhaps something that, that can be taken up by ISGF.
Yes, sir.
Anyway, any other
Yes, sir.
question?
Good afternoon, sir.
Where are you? Oh,
Yeah.
Thank you for this brief insight. My question is related to flute and especially to Mr. Mantiram, sir. Actually, Tata Power Mumbai also have experienced a lot of flutes and they have developed a methodology based on their experience. So now if they are implementing it in Odisha, so how was the journey with that? How was your journey with like implementing the mental utility to utility, as it was mentioned that it diversifies? So what was your experience with Odisha, like for the flute especially? And also Assam and Kerala experience of lots of flutes, and there's also one requirement to, to learning experience for them as well.
What he would like to know is, having been dealt with Bombay, now having come here, what transition, what differences or do you see now running two different styles of needs, basically?
No, is it related to technical or HR or?
No, I think technical. Technical is what I mean.
Okay. No, it's, I mean, if I mean, since I was there in Bombay for a long time, and eventually sometime in Delhi and now here. Bombay, if you see, I see Bombay as a world-class supply system, absolutely world-class system, thanks to the earlier BSES days, Reliance days. So when you talk about SAIDI, SAIFI in minutes, I think you are there, and in terms of what you're giving to the customers part of it. But then to arrive at that, the way the utilities went about structuring over the years, it just didn't happen in a jiffy, but over the years, the way the underground system was planned, and then eventually the entire technology was used, be it the SCADA and the way we used to communicate also. Even our distributing substations at one point in time had fiber optics to see that we even know the DSS can be monitored. So from that to this, it's like a huge difference. So as earlier it was pointed out by Arvind, from a no maintenance situation, so you can imagine what's the kind of work that needs to be done. So obviously, no maintenance, there were reasons in terms of fund not availability, not that the intent was not there. So there were challenges in terms of the management part of it. So from that point of view, I think our strategy in terms of structuring this whole journey is more about prioritizing. So one is to see that since Bhubaneswar is a capital city, Cuttack is the twin city part of it, is to bring to that level. So if you take Bhubaneswar today, it does have underground cables in certain parts where the government has supported. So specifically the 4 critical roads. So even in Bhubaneswar, there are certain parts where the SAIDI SAIFI is in minutes, okay? Certain parts. So obviously that will get replicated to the other parts of it. So today, the entire, as yesterday the power secretary was sharing, we have unmanned power stations in the entire Bhubaneswar, and this we have achieved it in the last 1.5 years itself. So, but then the SCADA was there, we revived it. So in terms of a journey, today you can find out what is Naveen Nivas. So Naveen Nivas, we monitor the supply 24/7 in our PSEC. So we have technology is firmly what we believe as an organization. And in terms of the way forward, like as I shared GIS, for example, by the end of this year, we would have mapped our entire license area on the GIS part of it. So our adoption to technology and ramping it up and leveraging it is going to be our approach as we take it forward. And the biggest challenge when I look at Odisha is in terms of the cyclone part of it. So as I firmly believe, while we can best do with what a DMP is, but we would build a network which would be disaster resilient in the next 10 years. But when you look at even today, California, as he rightly shared, if the network is put 50 years back, 60 years back, even a country like US cannot afford to put a new network, because eventually the customer has to pay. So what does California do today when a fire happens? So now they are thinking about microgrids, because why would anyone put a network all across the forest and bring supply? That time microgrid was not there, but today they cannot put a network, so they're coming out of it. So I think leveraging, so we are also thinking in terms of how to reach out to the farthest tribals in terms of the microgrid part of it. That's the easiest solution which we can have. So it's a good exciting time for us, huge number of challenges. Thanks to technology, thanks to digitalization, we would find right solutions as we take this journey forward.
Sir, any insights for flooding in Assam or Kerala? Like this methodology should be, implemented, adopted like a knowledge sharing platform for the flood, especially flood resilience distribution planning.
Address that to Reggie. He should be taking all these clusters, Kerala, Assam, all that, and put him to work. Put him to work.
I don't know if you were there yesterday. Yesterday, the past secretary of Kerala did share some of his views.
But even within the three states, you may find the terrain slightly different. What Kerala faces, what Assam faces.
Exactly,
because of the hills, the Cherrapunji range, rains, very different, right? So even there you may have. Now we'll have time for only one last question.
Sir, I will.
Sorry, my question is once again to Shenbagam Mantiram. Actually, basically, cyclone and tsunami are very less common on western coast, but recently we are also experiencing in terms of Nisarg cyclone was there, then Taukte was there, and a lot of our distribution systems actually basically was affected, and most affected were LT lines, and basically we have taken up some project in coastal areas like Raigad district for underground cabling. You have mentioned that in fact your power utility is basically proposing some kind of disaster cess on the consumers. Basically, if you see this underground cabling, so this is very capital intensive. And you also talked about disaster resilient distribution poles. So comparing, like if you compare this underground cabling and disaster resilient distribution pole from cost benefit view, so which is more better, and what is, I think in Puri you have done almost 100% underground cabling. And also instead of basically putting like disaster cess, there are some funds like with Government of India, disaster relief fund, national disaster relief fund, NDRF, and some of the state government like Maharashtra has also put up Maharashtra state disaster relief fund. I think you must be getting actually financial support from this fund. So if we get financial support from this fund, so instead of putting disaster cess on consumers, so that is a better way, so that consumers are not burdened with it. So what is your experience in Odisha power utilities regarding this?
Yeah, one is underground network is definitely not a solution because of the cost impact part of it. But if one prioritizes where to be used, even in smaller towns, that becomes a necessary, be it the hospital, be it important installations, where you anchor those places on a long-term basis, the supply is available for them. And then, like in our case, our expense we found out we require 10,000 crores to really make our network disaster resilient. This was our estimate. Obviously, that's not the type of money one can look at. So we continuously have worked, and in the initial year, based on the earlier disaster fund, we got 250 crore. And we really used it in some of the coastal areas. Now there, even putting the network in a systematic way, that itself solves half the problem. And when you do that, it's ready to withstand with your systematic design at least 200 kilometers per hour. Now anything beyond that is really something where you need to put the money, as well as there is the time span is going to be different. Having done that, with our advocacy, what I look at is government does understand in terms of the challenges of the Discom. So we would be getting anywhere around 50 to 100 crores every year to see that we are able to build this disaster resilient network, which may not be adequate, but at least we can start working upon it apart from our capex. But when you put a cess of as less as 1 paise or 2 paise, I think it's an amount which no one would bother. At the same time, you are using it for a cause. On a long-term benefit, it's really, really good enough. So when I look at Japan, for example, it has got entirely an overhead network, but the design of that is pretty much adequate to withstand it, except for the once in a blue moon cyclone, where the moment it crosses 200 kilometers, their network also cannot withstand. So I think that balance, if we do, understanding what's the cost impact, and then prioritizing systematically, I think we should be able to overcome that. And even when the cyclone comes, the impact is going to be less, and we should be able to restore in times to come. So it's going to be a mix and match of all this put together.
Mr. Srinivasan, any comments to add? I know you're doing a lot of undergrounding work for various utilities as well as an EPC contractor. Is there some way you're finding costs can be saved in the installation, or is it going to be as expensive as generally it has been with respect to undergrounding?
No, the basic cost comes from the cable cost itself when compared to the overhead line. Add-on is the digging cost. So the cost differential at this point is still high in comparison to the overhead lines. So I think that in the near future to bridge may be very difficult. Yeah.
Now just to add, why do cyclones come to places where cyclones do not come in the is because of the warming up of the ocean. That is what has happened everywhere. So even though the western part may not see cyclones, expect more cyclones in the times ahead, because all the oceans are warming up, especially in the shallower oceans, which is, the Arabian Sea is one. So that's why Caribbean islands and the southern Florida, which used to get 6 or 4 cyclones a year, are now getting 16 cyclones a year. It's because the Caribbean and the Florida coast is warming up with respect to the ocean waters. So I think this is just the beginning that you're going to see this particular pattern of hurricanes and cyclones coming up. So I think with that, we will probably close. First of all, a round of applause for this excellent panel. They have shared knowledge, wisdom, practices, standards that all of us probably, we should really thank them. So once again, thank you very much.
Thank you, sir. Excellent session, rich content, discussion, deliberations, and interactions. So it speaks about the kind of effort, the volumes of the effort and the planning part which goes before we design the system and run the businesses. And with the changing time, things will keep changing, and we'll have to discuss, deliberate, learn from the best practices, whether nationally or locally in our context, and maybe find more innovative solutions to the business. So thank you so much, Ravi Sitapatiji, being in the chair, and all the distinguished speakers here, and to all the audience. I would request